Hello everyone, I am Arnab. I am from West Bengal. I have completed my BSc from Midnapur Autonomous and I have been selected for various institutes like IISER TVM, IISERs Kolkata. Today I am going to share my first interview experience at IISER TVM. For IISER TVM, I gone through a written exam. Then I have been selected for MSc and IPhD both program and then the interview happened on online mode. There are four professors in the panel. They asked me about my favorite topic. I told quantum mechanics, mathematical physics, and thermal physics also. So let's start the interview questions. At first, one of the professor asked me that if the volume of the ideal gas is doubled, then derive the work done in case of isothermal, adiabatic, and isobaric process and compare them. We know the formula of work done, W equals to integration of 3 dt. For isothermal process, that is temperature T equals to constant. So solving this integration, we can easily find that the result is RT log 2, that is equals to 0.693 RT. And for isobaric process, that is pressure P equals to constant. And solving this formula, we can simplification after simplification, we go get the result equals to RT. And similarly for adiabatic process, the result for PI substituting the values in the equation, we get less than 0.605 RT. Comparing these three results, we can easily see that W at isobaric greater than W at isothermal greater than W at adiabatic. Then one professor asked me to draw the PV diagram of isothermal, adiabatic, and isobaric process and also experiments. First, I derive this curve for isobaric process, that is volume equals to constant. So we get this straight line. And for adiabatic and isothermal process, the graph will be like this. For which is triple, I just goes through this formula. For isothermal process, T equals to constant. So dT by dV equals to minus P by V. That is the slope of isothermal process. And similarly for adiabatic process, equation of state we know P by gamma equals to constant and dT by dV equals to minus gamma P by V. That is gamma times the slope of isothermal process. So the adiabatic process is much steeper than isothermal process. Then they asked me just to derive the work done in case of adiabatic process. For this, I just go through this problem, that is P divided by gamma equals to constant. So going through just substituting the value of P in this equation and then simplification, I got the result in as 1 minus gamma minus 2. Then one professor just asked addition to this problem that what will be the graph if we just use diatomic instead of non-atomic. So for this, I again got this equation of state of adiabatic process P dT by gamma equals to constant and the slope from dP by dt, that is the slope of the graph, that is minus gamma P by V. As we know for monatomic gas, gamma for monatomic is greater than gamma for diatomic. So the graph will be like this, that is for monatomic gas the graph will be much steeper than diatomic gas. Then one professor asked me, what do you mean by gamma? Gamma, that is equals to Cp by Cv, that is specific a ratio of specific heat at constant pressure and the specific heat at constant pressure. Then one professor asked, what can gamma ever be less than 1? I told as Cp always greater than Cv, that is Cp by Cv is always greater than 1, that is gamma is always greater than 1. Then they asked one question on mean free path. They asked me what do you mean by mean free path. I just told mean free path means average distance traveled by molecule between two successive collisions. And then they asked how mean free path depends on temperature. So for this we know the formula of Maxwell mean free path formula, that is gamma lambda equals to 1 by root 2 pi a t square, that is n is total in the number of mole per unit volume of the volume, and it is the diameter of the gas molecule. And just substituting the values, I got gamma is proportional to temperature T. Then they just give me a problem on thermodynamics, that is let a container of volume V contain an ideal gas. If the temperature is changed from T to T, then how the mean path will change. Here we know gamma equals to 1 by root 2 pi v square. Just n equals to here total number of gas molecule and by total volume of the container. Here as the volume is constant, so if we increase the temperature for T to 2T, the kinetic energy of the gas molecule will increase. So their collision time will decrease, but as the volume of the container is constant, so mean free path remains constant. Then they just asked me from some question on quantum mechanics. That is, the one professor asked me to draw the wave function of harmonic oscillator. So I just draw this graph, that is n equals to 0 and n equals to 1, that is for ground state wave function. This is fast excited state wave function and so on. Then in addition to this question, one professor asked me if a infinite potential is placed at x less than equals to 0, what will be the, then asked me to draw the wave functions. Actually, this is the problem of truncated harmonic oscillator. That is, we know at infinite potential the wave function will be 0, and then we get the ground state wave function will be like this, and fast excited state wave function will be like this. Then they asked me what is the measure of harmonic oscillator potential. We know actually Vx equals to half kx square. That is, we know it is graph will be, it is parabolic in nature. Then they asked me to draw it. Just I go through this and draw it. At last, they asked me to draw some graphs. So first one professor asked me to draw this graph. So we know that this is a standard equation of ellipse, that is like this. It will be where this is A and this is B. Then the one professor just modify this equation to second one and ask me to draw. So I just draw like this. As we know from the previous one, this is x squared by square square equals to 1, and the second one will be like this. Just constantly like graph we will get, that is x by 4 by p equals to 1. Then one professor asked me to draw this third number graph, that is we all know this is y, and from this we know This is the equation of circle. Square square one. You get like this. Is to the power of so this is my interview experience. And thank you. So that's it. Thank you, Soto sir and Physics Galaxy, for giving me this opportunity to share my interview experience at IISER TVM. So it might help you in for your further preparation.